Hello everyone, welcome to my channel GVS Chem. In this video, let us discuss the basicity of amines. Please subscribe to my channel, like, share and comment on my videos. In this video, let us learn the basic nature of amines. Amines are RNHT, NH2. Nitrogen atom of amines have a lone pair of electrons, and this lone pair can be donated to the atoms who are in necessary. Therefore, amines are Lewis bases. Therefore, RNH2, so this is the lone pair, plus in water, in the presence of water, because of this lone pair it accepts a proton, so RNH3 plus OH minus. So if we write the equilibrium constant K equal to RNH3 plus into OH minus by RNH2 into H2O. Now, since the substance is dissolved in large excess of water, so the concentration of water, let us bring this to this side, K into H2O. Since water is constant and this is a constant, therefore we can take it as another constant, that is Kb. Kb equal to RNH3 plus into OH minus by RNH2. So this Kb is known as a dissociation constant of base. Dissociation constant of base. Right. As a dissociation constant of Kb is known, we can find pKb. pKb equal to minus log Kb. Now, what is the relation between the values of Kb or pKb and basicity? So here, greater the value of Kb, greater the value of Kb, or smaller the value of pKb, smaller the value of pKb, then stronger is the base. Stronger is the base. Stronger is the base. So this is the relation between Kb value and basicity of amines. Now let us discuss the different basicity of different types of amines here. So the basicity of alkyl amine and ammonia. Alkyl amine and ammonia. So this is alkyl amine NH2, of course lone pair, and this is the ammonia lone pair. Now we know that alkyl groups are electron releasing groups, so they show plus I effect. So as alkyl group donates the electron density towards the nitrogen, nitrogen has a greater tendency to take the proton from other substances when compared to ammonia. Therefore, alkyl amines are more basic than ammonia. So the basicity order of these is RNH2 is more basic than ammonia. Now let us discuss the basic strength of different class of amines. Basic strength of alkyl amines. So here this is RNH2 primary amine, this is secondary amine, and here this is tertiary amine. Tertiary amine. This is tertiary amine. Just now we discussed that alkyl group is electron donating group. So it has a plus I effect. Therefore here it donates electron density towards it, due to which what happens, the electron density of nitrogen atom becomes more, therefore it is more readily accepts the proton. Whereas in secondary amine, there are two alkyl groups. Therefore, the electron density donated on nitrogen atom due to these two alkyl groups is more than that in primary alkene. Coming to tertiary amine, here there are three alkyl groups. Therefore, the electron density donated towards the nitrogen atom is much more greater than secondary and primary. Therefore, basic strength of alkyl amines, is expected as tertiary. Basic strength of tertiary amine is greater than secondary amine is greater than primary amine. So this is true. This is the expected value is found to be true. It is observed in gas phase. So in gas phase or non-aqueous medium, the basic strength of amines is in this order. Tertiary is greater than, secondary is greater than primary. But in case of aqueous medium, that is in aqueous solutions, this order is not followed. Why? So why this order is not followed in aqueous medium? Let us discuss now. In aqueous solutions, the basic strength of alkyl amines RNH2 follows the order of CH3 methylamines, CH3 twice NH. This is secondary amine. Basic strength of secondary amine is greater than CH3 NH2 is greater than CH3 twice N. So basic strength of secondary amine is greater than primary amine, greater than tertiary amine. In case of ethyl amines, C2H5 twice NH. So in case of ethyl amines also, the basic strength of diethyl amine is greater than, this is C2H5 taken thrice N is greater than C2H5NH2. So the basic strength of alkyl amines differ in a different series. Why it is so, now let us see. In aqueous medium, the basic strength is determined by stability of protonated ion. The basic strength of amines in aqueous solution is determined by the stability of protonated ion. The stability of protonated ion or amine, is determined by, number one, hydration effect, and the next one is steric factors. Hydration effect and steric factors. Now let us discuss about these two in detail. Hydration effect means, for example, this is RN. So here this plus indicates H. That means this amine is already protonated. So one excess hydrogen is there. That means it is protonated. So this protonated amine make H bond with water in this manner. So this also make H bond with water, hydrogen. So here also make H bond. So primary amine can form 3 hydrogen bonds in water. Coming to secondary amine, this is R2NH. So this is the hydrogen coming due to the protonation. Therefore, in secondary amine there will be, this is H bond and here there is another H bond. So in secondary amine the amine can form only 2 hydrogen bonds, whereas in primary amine it can form 3 hydrogen bonds. Coming to tertiary amine, R3N, so the protonated amine has only one excess hydrogen, therefore it can form 1 H bond. Right, now greater the number of H bonds, greater is the stability. Now this is a primary amine, here it is secondary amine, this is a tertiary amine. So in primary amine, the number of hydrogen bonds is more in number, in secondary it is 2 only, in tertiary it is 1 only. Therefore, depending on the number of hydrogen atoms, in which case the stability of protonated amine is greater. So in primary, the stability of protonated amine is greater in primary than secondary than tertiary. So when hydrogen bond forms, when amine dissolves in water, this is NH2, therefore this forms R. This is amine cation after protonation takes place, therefore this is hydrogen bond with water, hydrogen bond with water, hydrogen bond with water. So here when hydrogen bond forms, energy releases. So the released energy when amine forms a H bond with water, therefore this energy is known as hydration energy. So greater the hydration energy, that is greater the number of hydrogen bonds formed when it is dissolved in water, therefore the stability of cation is more. Therefore primary amine cation is more stable than secondary, is more stable than tertiary. Now this is about the hydration energy or H bond formation. Not only that, there are steric factors also. Steric factors. So what are steric factors? Suppose we take nitrogen, this is R. So these are alkyl groups, right? Alkyl groups, the crowding, the steric factor is nothing but crowding means the bulkier groups. Bulkier groups come closer with respect to an atom, that is known as crowding. So crowding of alkyl groups on nitrogen atom. So because bulkier groups come near to the nitrogen, therefore they do not allow H plus ion to come and attack on nitrogen atom. Therefore this is nothing but steric factors. So the effect of steric factors, that means greater the number of alkyl groups, greater is the steric factor, therefore lesser is the attack of H plus ion. So steric factors, tertiary amine, steric factors of tertiary amine is greater than, secondary is greater than primary. Now combining these two effects, so after combining these two effects, what are the effects? One is hydration energy or formation of H bond and steric factor. So formation of H bond and steric factors. So after combining these two effects, now the secondary amine is more basic than primary, is more basic than tertiary. See here, since methyl groups are smaller groups, methyl groups are smaller, so they cause less hindrance to form the H bond. They cause less hindrance, that means less obstruction, less hindrance to form H bond. Since CH3 groups are smaller, they cause less hindrance to form H bond. Thus, the order of basic strength of methyl groups, CH3 twice NH2, that is secondary. This is NH is greater than CH3, NH2 is greater than CH3 thrice N. So tertiary, secondary is greater than, primary is greater than tertiary. Now let us discuss the basic strength of ethylamines. Basic strength of ethylamines. C2H5NH2, C2H5 twice NH. This is C2H5 thrice N. So primary amine, secondary amine and tertiary amine. Ethyl groups are more bulkier than methyl groups. So ethyl groups, because the molar mass is more, ethyl group is more bulkier than methyl group. Right. So in ethyl amines, the plus I effect predominates the stability due to plus I effect of alkyl groups. Plus I effect due to ethyl groups predominates, that is predominates than the stability created or stability given by the formation of H bond, than the stability caused by the formation of H bond. Therefore, so combining these two effects, that is plus I effect and the formation of stability caused by plus I effect and stability caused by hydrogen bond, combining these two, C2H5 twice NH, the secondary amine is more basic. This is secondary amine is more basic than C2H5 thrice N. So here the stability caused by plus I effect is more than that of H bond, is greater than. This is C2H5 NH2, this is NH2. So in ethyl amines, the basicity order of ethyl amines is secondary is greater than, tertiary is greater than primary. Whereas in methyl groups, methyl amines, the basicity order is secondary is greater than, primary is greater than tertiary. So this is the basicity order of alkyl amines with different alkyl groups. Now let us see the basicity of aromatic amines. What is aromatic amine? The aromatic amine is aniline. So aniline is C6H5NH2. So this is aniline. And of course this is the lone pair of electrons. In aniline, the lone pair of electrons present on the nitrogen takes part in the resonance. So lone pair of nitrogen takes part in resonance with ring. Therefore what will happen? This lone pair shifts to here. Therefore this pi bond shifts to here. Therefore we get the structure becomes so this gets a negative charge and this becomes nitrogen gets a double bond. So plus here, minus here. Now this negative charge shifts here and this bond shifts here. Therefore we get here, this is so double bond nitrogen NH2 plus, and here it is the negative charge. So this is the negative charge, right? Now this negative charge shifts to here, this pi bond shifts to here. Therefore we get in this manner. So double bond nitrogen with the positive charge, and here it is negative charge. Now finally this negative charge shifts here and this double bond shifts here. Therefore, we get in this manner. Nitrogen, NH2, this is lone pair. So since lone pair is involved in resonance with the ring, the ability of accepting the proton becomes less because the electron density becomes less. So since lone pair is involved in resonance, the ability of accepting proton is less when compared to ammonia. When compared to ammonia. Therefore, aniline is less basic. So here this is basicity order. Basicity order of aniline. So aniline is less basic than ammonia. So finally, if we compare the basicity of aromatic amines, ammonia and alkyl amines, so here alkyl amine is more basic than ammonia, is more basic than aryl amine, that is aniline, ARNH2. So we discussed the basicity of aromatic amines, that is aniline is less basic than ammonia since the lone pair present on the nitrogen atom is involved in resonance, right? If some group is present on the ring, then how the basicity varies? So variation of or change of basicity of ARNH2 based on groups present on the ring. So here if electron releasing group is present. Electron releasing group means electron density is set towards the nitrogen of amine. So this is ERG. What are ERG? This is OCH3 alkyl group, nitrogen. These are the electron releasing groups. So when electron releasing groups are present, the presence of electron releasing groups, presence of ERG increases the stability of anilinium ion. Anilinium ion means after the NH2 group is protonated, stability of anilinium ion. Therefore, basic strength increases. If electron withdrawing groups are present, electron withdrawing groups means electron withdrawing groups are nitro, cyano, halo, etc. If such groups are present, the presence of withdrawing group decreases the stability. Therefore, they decrease the stability. They decrease the stability of ARNH3 plus ion, anilinium ion. Now let us take an example. If methyl group is present on aniline, so this is CH3. Paramethyl, this is NH2. Paramethyl aniline is more basic than simply aniline. Aniline is more basic than NH2. Parachloroaniline is more basic than paranitroaniline. So if different groups are present on aniline, so the basic order is paramethyl aniline is more basic than aniline, is more basic than parachloroaniline, and more basic than paranitroaniline. If EWG is present, that means electron withdrawing group. So the effect of electron withdrawing group means it destabilizes the cation. So the presence of EWG destabilizes cation. Let us say EWG is this is EWG. If electron withdrawing group is present on meta position, it is more basic than the compound with EWG at para position. So this is meta isomer, this is meta isomer, this is para isomer. So meta isomer with EWG is more basic than para isomer. Similarly, if ERG is present, ERG means electron releasing group. If electron releasing group is present, for example, if a methyl group is present, so this is methyl group is more basic than the methyl group present at para position. So this is CH3. So this is a para isomer, this is meta isomer, this is meta methyl aniline, meta methyl aniline. Now, irrespective of the group, whether it is ERG or EWG, so ERG or EWG, if it is present on ortho position, so is at ortho position, it is weak base than aniline. So irrespective of the group, the reason is due to steric factors. Due to steric factor, so it becomes a weak base. Now the effect of group on basicity of aniline depends on I effect and R effect. So the effect of group means maybe ERG or EWG. So the effect of group on basicity depends on I effect or I effect and R effect. I effect and R effect. I effect means inductive effect. R effect means resonance effect. Let us take nitro group. So if we take nitro group has minus I effect, that is electron withdrawing inductive effect. So electron withdrawing inductive effect. Electron withdrawing inductive effect. Similarly, resonance is minus R effect. Minus R effect means here also electron withdrawing resonance effect. Electron withdrawing resonance effect. So these two factors, the effect of group affects the basicity of the aniline. So among the substituted nitroanilines, this is aniline. Aniline is more basic than metanitroaniline is more basic than paranitroaniline is more basic than orthonitroaniline. So among nitro substituted anilines, aniline is more basic than metanitro, because nitro group is electron withdrawing group. So it has electron withdrawing inductive effect and electron withdrawing resonance effect. Because of both of these, the aniline is more basic than other substituted amines. Now if we see CH3 group has plus I effect and plus R effect. That is electron releasing inductive effect and electron releasing resonance effect. So because of these two, the basic order of these methyl substituted amines anilines are, so this is NH2 CH3 paramethyl aniline is more basic than metamethyl aniline is more basic than aniline. NH2 is more basic than orthoisomer. NH2, this is orthoisomer. So this is the order of basicity of methyl substituted anilines. Now, if minus I effect and plus R effect, if the group has minus I effect and plus R effect, what are such groups? Such groups are OCH3 NH2X halo. So in such cases, how the change takes place? So in case of OCH3, at meta position only minus I effect causes, therefore it is weakly basic than aniline. It is weak basic than orthoisomer. So at meta position only minus I effect causes, therefore weakly basic. And on the other hand, among ortho and para isomers, para isomer is more basic than aniline. Therefore altogether it is written as this is para isomer is less than aniline, is less basic than NH2, less basic than orthoisomer, is less basic than meta-isomer. So this is the order of basicity of group which has a minus I effect and a plus R effect. So now let us see among aminophenols. What is aminophenol? This is NH2, this is OH. So this is aminophenol. This is orthoisomer. In this orthoisomer, intra-hydrogen bond is present. So this is hydrogen. This is hydrogen, and of course here this is water. This is hydrogen, this is hydrogen. So in between these two, H bond is formed. This is H bond. Therefore, due to this intra-hydrogen, this is intra-H bond. Because of the intra-H bond, anilinium ion is more stable. So here orthoisomer is more basic than aniline. Therefore orthoisomer is more basic than aniline. Orthoisomer is more basic than aniline. Therefore let us see here the basic order is this is ortho para-isomer is more basic than, this is orthoisomer is more basic than, this is aniline is more basic than meta-isomer. This is NH2, this is OH. So this is the basic order of aminophenols. Now let us see NH2 group. NH2 group has much stronger much stronger minus I effect and much weaker plus R effect. Much weaker plus R effect. So under such conditions, what will be the basic order? Let us see. So here this is para-isomer. Para-isomer is more basic than meta-isomer. Is more basic than aniline and more basic than orthoisomer. So this is the basicity order. So let us see another group, weak plus R effect and strong minus I effect. Weak plus R effect and strong minus effect. What is such group? Such group is say chlorine or halogen. Therefore in this case NH2 is more basic than this is a para-isomer, is more basic than this is a meta-isomer and is more basic than this is orthoisomer. So in this module video we discussed the basicity of amines, aliphatic amines and aromatic amines, discussed in detail.